sure you guys do these in middle school, so it shouldn't be brand new. We simplify what you guys do with proofs versus what you guys did in middle school. So let's first talk about a few properties that you might need to know for proofs on this slide here. So the addition property of equality. Thank you for telling me though, because you guys would probably, some people would probably just sit there and be like, oh well, I just don't have to write anything down. Is when you add the same number to both sides. So the addition property of equality is when you add the same number to both sides.
Whoa. Oh my goodness. Everyone's dying. Get a drink.
The subtraction property of equality is when you subtract the same number on both sides of the equation. Make sure you're writing stuff down, guys. There's stuff appearing on the board maybe for some of you. No one should be talking. The multiplication property of equality is when you multiply by the same number on both sides. The division property of equality is when you divide by the same number on both sides. The distributive property of equality. So exciting, I know. Thank you for telling me how exciting this is. Is when you multiply a number into the parentheses. I guess I should say to all terms inside of a parenthesis. We'll shorten it. I'm going upwards with mine. That means parentheses, because I didn't feel like writing the word parentheses. The substitution, so substitution is substitution. It's when you either combine like terms on the same side of the equation or simplify. Or simplify on the same side of the equation. I only have one one more that you guys need to know for our proofs. And then finally, the symmetric property is when you flip it over the equal sign. Okay, so go ahead and get that stuff written down, and then we will do a few examples of proofs. I'm going to show you two different ways to do the first proof, and then I'm going to do like the shorter way for the rest of them, but I just want to give you guys two different ways of doing it, just so you've seen both ways, and then I'll give you the shorter way on the rest of them. If you can't see something, let me know. Okay, so I'm going to show you two ways to do the first proof. What I always tell my students to do first is just solve the problem off to the side. So like, there's not a lot of room on your worksheet, so I would do it on a separate sheet of paper and just solve it and then put it into the proof. It makes it a little bit easier to see the problem. So if we were just to solve this, Jayla, what would you tell me to do first? Alyssa, then what would you tell me to do? Okay, so I always tell my students to do that first and make sure they get the proof answer. Because if you didn't get the proof answer, you probably did something wrong. Alright? I mean, there's like a slim chance that I made the worksheet wrong, but it's a much better chance that you did something wrong. Just throwing that out there. But there is also a chance that I did something wrong. So that percent of the time, that I do stuff wrong. I do stuff wrong all the time. But I'm saying on the worksheets, I tend to fix that by now. Anyways, so there's two schools of thought on how you can write this proof up. So we're going to do the first one. What you always do first is write down your given statement. Does anybody remember either from Math Lab today or from last year when you write down your first statement what your reason is? Mike? It's given to you. Okay, so then kids often think then when they get to the final answer, they write prove. That's not the case. I should never see the word prove in the answer. And I understand why you guys think that. You write down given for the first one, right? So why wouldn't you write prove down? Because it says prove next to x equals -6. That is never the case. All right? So please do not put prove in your proofs. Now, everybody should be able to do this much. This should be something that you can do. You're literally just writing down the given information. So from there, you'll notice that we added 10 to both sides. Do you guys see that? So one school of thought is to show all your work in the proof. So one school of thought with proofs is to show all your work in the proofs. So this is all work shown. So what did we do on both sides in this part here? So what did I do on both sides, Kaylee?
The addition property.
Yeah, we added 10 to both sides. So you hear the word adding. So Kaylee said that's the addition property of equality. So you hear the word adding, right? You added 10 to both sides, so that's the addition property of equality. I am going to put POE there. That means property of equality. So whenever you see POE, that means property of equality, instead of having to write that out 1,000 times. Shorten things up. Addition PO. So then we have to simplify it, but we never ever use the word simplify or combine like terms in a proof. If you look back up to your definitions on that very first slide, Which thing did I say means simplify or combine like terms? Which one of those words meant that? Connor?
Substitution.
Substitution property. So it's the substitution property. Here is why it's substitution. Substitution means you replace something is the same for something else. Well, what is negative 10 plus 10? 0. So we replace negative 10 plus 10 with 0. What's negative 40 plus 10? So we replace negative 30 with negative 40 plus 10. That is the definition of substitution. Okay, then I show my work again. What did I... Oops, I just numbered 3 twice. I'm really good at numbering things here. What did I do on both sides? What did I do on both sides here? Riley?
Divided by 5.
So you're saying the word divided, so what property should you write down?
Division property of equality.
Division property of equality. Again, POE stands for property of equality. Then we have to simplify. 5 divided by 5 is just x. Negative 30 divided by 5 is negative 6. But we never use simplify or combine like terms, Brian. What do we use instead? What word means simplified or combine like terms on the same side of the equation? Substitution. Okay, so that is how you do it with work in the problem. We're going to do it without work, and then I'm not going to do this again with any of the other ones. So make another thing off to the side for me. So one of them is no work, and one of them is all work shown. I do not care which way you do it on your homework as long as what you're doing is correct. Does that make sense? I'm giving you multiple ways to do things because some people like to show their work. But this is why I tell you guys to do the work off to the side, because then you really don't have to show your work in the proof. So we still start with the given information. What is our reason for starting with the given information no matter what, Grace? What do we always write down when we write down the given? We write down the equation and what goes in the reason spot no matter what? Given. All right, well, we added 10 to both sides here, and where did that get us to? When we added 10 to both sides, where did that get us to? Do you see how we added 10 to both sides and we got there? So step 2 could be just skipping that showing adding by 10 and just saying 5x equals negative 30. How did you get there? Well, you added 10 to both sides, didn't you? You guys see that? Well, if I'm adding 10 to both sides, Emma, what would my reason be then? So notice I just skipped my showing work. I just said from here to here I get 5x equals negative 30. To do that I added 10 to both sides, but I'm not showing work in here. And you may not show work in here if you're going to do it that way. But all that means is I added 10 to both sides to get here, so that's the addition property of equality. Mike?
Why can't you just, on the all work side, just go like up there?
You can't because it's a proof. It has to be within like the line. It's a little bit different than like when you're just solving it. Okay, so from here to here we can just go to the answer. So that means that x equals negative 6. Well, how did we get there? What did we do on both sides, Colin? What did we do to get from here to here?
We divided 5 on each side.
So what reason would we do if you're saying divide it by 5 on each side, Colin?
Division property of equality.
Good. So that one's a little bit quicker. You just have to, I would always show your work off to the side first before doing that, which means that on tonight's homework you might want to pull out a separate sheet of paper and do your work there and staple it when you go to turn it in tomorrow. All right? Does everybody understand that?
Yep.
What'd you say, Riley?
If the work is that easy on the Millwork side, why would anyone go back to the...
I don't know. It's their choice. Everybody gets to make their own choices. All right, when you're ready, go ahead and flip to the next page unless you have questions for me. I'm going to do everything without work now. I'm just going to show like my work off to the side and then put it into the proof. Okay, so I'm going to solve it over here just to make sure that I get the right answer. Get your calculators out if you do not have your calculator out, because there's a fraction in this one. Get your calculators out if you do not have your calculator out.
Calculator is currently out.
Okay, so the first thing I do here is distribute this 3 in. So that's 3p. Who can tell me what 3 times negative 5/3 is? What's 3 times negative 5/3 if you've done it already? Mike?
Negative.
It's negative 5. Put it in your calculator if you don't agree with me and see if you get the same thing, because you should get negative 5. So some of you didn't make it negative 5/3. Does everybody understand why it's minus 5 here? This is a positive 3, that's a negative. You take the sign that's in front, a positive and negative is a negative. Josh, what would you do now?
You would add the like terms.
And what would you get?
3p plus 0 equals 6.
And we don't have to put plus 0 there, but you did. You combined your like terms. Very good. That's fine. You didn't do anything wrong. Justin Powers, what would you do now? Did we get the answer that is up there on the board?
Yes.
Okay, so we need to go through and do our steps now. So what is the first thing I always do, Gianna? Very good. So she said, put my given equation and your reason would be given. Okay, so from step 1 to step here, which would be step 1 to step 2, Cassie, what did we do? We did the distributive property. So to get that answer, we did 3p minus 5 plus 5 equals 6. And we used the distributive property. You may not skip steps, okay? You have to write everything out. So if you're doing multiple things at once, that's not going to work unless they're the same property. So you cannot do multiple things at once unless they're the same property. So you can't combine the 5 and the negative 5 yet. Okay, so from here to here we got 3p equals 6. How did we get 3p equals 6? What did we do? What did we do to get 3p equals 6, Blaine? What property did we use? Yeah. Very good. Notice he did not say combine like terms or simplify. Those are not properties. You use substitution. Negative 5 plus 5 is the same thing as 0. I think Josh is the one that said plus 0, which is good to think that way. It substitutes 0 in. They're the same thing. So that's substitution. And since I'm not going to be showing work, I'm just going to go from here to the answer. So I'm just going to go from here to the answer to get p equals 2. How did I get p equals 2? What did I do, Tanari, to get p equals 2? Yeah, you divide it by 3, so you hear the word divide it, so that means the division property of equality. Okay, questions on that one? Are there questions on that one? Go ahead and get that written down. Again, some of you guys aren't doing what I asked you to do, and that is write the work off to the side. That's something I know that you guys are like, oh, but that's more work, but you're going to be more likely to do things correct. Number 2, I'm walking around and some of you are not numbering all of your steps on both columns. You must number your steps on both columns. I cannot read chicken scratch, slanted writing, and I have no clue which reason goes with which property. So if yours happen to not line up, at least if you have a 1 and a 1, I know those 2 line up. Does that make sense? Most of the time we'll give you lines, but when we don't, you need to number both sides. So just a few things that I noticed while I was walking around, okay? All right, one last problem. We're going to solve it off to the side here. So what would we do first in this one? Justin, what would you do first in this one?
Thank you.
Yeah, when you multiply by 2 on both sides, you need to make sure that you give it to everything over here. So that cancels out there, so that's x plus 1 equals negative 6x plus 190. Jordan, what would you do now?
I would
Brian, now what did you do?
You would subtract 1.
Lexi, what would you do now?
I would divide by 7.
Is that what we needed to get, was 27?
Yep.
Okay, so we start off with what, Lamar? What do we start off doing? What is the first step in all of our proofs? So if we look back here, the first step we did here, and the first step we did here. What is the first thing we need to do here? But what did we do before the distributive property? What do we have to do first in every proof? Write down what? The given information. So we need to write down the given information, and our reason is given. Okay, we are going to skip some steps here. Yes, we used the distributive property, but really to get to the answer, what did we do? But really, what did we do to get to that answer? What did we have to do first before we even use the distributive property? Alyssa? So we use the multiplication property of equality here. So this is the multiplication property of equality. So I'm skipping the simplification part of it and calling it the multiplication property of equality because I multiplied by 2 on both sides. So again, we're skipping showing our work. We're skipping showing our work, Emma. So we get to 7x plus 1 equals 190. How did we get to 7x plus 1 equals 190? So what is our property then? Yep, by adding 6x, you hear the word adding, so you should think the addition property of equality. Okay, Connor. What did we do to get to 7x equals 189?
Divided 189 by 7.
Not yet. What did we do first? To get from step 3 to step 4. What did we have to do to get to 7x equals 189? We subtracted 1 on both sides, so that would be the what? What property is that? Subtraction property of equality. Kaylee?
If you did it the other way, would you still be addition or would it be subtraction?
What did you do first? Subtract 1 first?
I subtracted that on both sides.
That would be the subtraction property of equality. Okay, which brings me to another point that I need to bring up before we finish then, because of how you did it. So that's the subtraction property of equality, and then we have one last step here, and then I have to address something because Kaylee brought up a really good question. Josh, how did we get that x equals 27? What did we do?
We divided by 7.
So what is our property? Okay, so that is your final answer. But Kaylee brought up a point. Kaylee, when you got to your answer, did you have 27 equals x?
Yeah.
Okay. You must rewrite your final answer how it is written. Do you see how the x is on the left side here? So what is the reason for being able to rewrite it as x equals 27? Symmetric property. If you look back on that first page, remember I said symmetric property meant you flipped it over equal sign? So if you get this answer, you are not done yet. You have to flip it over the equal sign, and your reason is the symmetric property of equality. Or sometimes we'll give you an answer that says 27 equals x, so you guys have to use that symmetric property. Just make sure you're using it. Does everybody understand what I just said there? Okay. Let me get your homework out to you guys.